Yeah, we started this whole process by writing algorithms and then specifying an input file that needs to be sucked into our platform and processed by our algorithms in order to provide different versions of production profile. But then we realized that customers need to get to a point when they have that input file, and it became important to enable customers to bring their data into our system in the form under which they have that data. Customers have production data, they have well deviation surveys, they have logs, sometimes they have geological models. It is important for us to provide them with an environment where they can integrate all that data, visualize all that data, pull it in from different repositories, and run our algorithms in order to aggregate them into something that can be consumed by our algorithms. So visualization is key. It helps you select the data. It helps you visually inspect the data. It helps you analyze the input and the output to the processing algorithms. And it helps you compare what you've predicted with what the input was. So it's just key. It makes the whole thing real. So we are an AI company. We are a machine learning / AI / first principles company. We do not specialize in building visualization widgets. And we knew of INT in our past lives, and also based on its evolutions and conversations we have with some of our customers. And we say, okay, we need to work to leverage widgets from a company that knows how to build visualization for the specific data of the oil and gas industry. And it was important for us that the visualization solution should have the possibility to be connected to a very wide array of data sources. It was important to us that there should be a wide breadth of widgets to represent different type of oil field data, and also different types of just processed data. So we looked at a few solutions, some of which were generic data solutions, data visualization solutions, and some of which were oil and gas specific. And the combination of a rich set of connectors to different data sources and a rich breadth of widgets and the integration of all that in the cloud environment made us decide that INT's IVAAP was the best solution for us. It brings a tremendous reduction in the cycle time to do a study for ourselves and for our customers. When you do a data-driven workflow, usually upwards of 90% of the time is used doing data cleansing, data curation, data aggregation. You need to be able to automate that process. What IVAAP brings us is the ability to automate that process. So you go from a situation whereby you're going to write a set of Python scripts for one particular study. It's going to take you 2 weeks to really curate and aggregate that data set, to a place where you have all of your scripts, all of your agnostic scripts deployed in an environment in such a way that in one afternoon, that whole process can be carried out. And we really cut into that cycle time, that 90+% of the time that it takes to bring the data into a form that can be used by the predictive algorithms. We really cut into that, and that's a huge value to the cycle time of a project.